So, so yesterday we started this lab, correct? And so at least you could able to understand what exactly we are trying to do in this lab. Okay. So today again, so we will complete this. So yesterday I will do one thing. So I will restart once again so that I will try to explain once again, try to understand how exactly the components are fitting together. Okay. So again, so I will start configuring the first this part, the data ingestion part, right? So we are using the data streams, right? So for that, what I will be doing is I have logged into my system. Okay, and in the account, I believe everybody were able to create some account, right? So I believe everybody has tried AWS account. If not, try to log in and understand the components here. Okay. So what we'll do now, I will start with the data stream, right? Okay. Okay, so we'll not use this. Okay, I will log out to this account. Okay, so I will log into the other account. Okay, just give me a minute. So I am trying to log into my other account. Just to give me a minute. Okay, so okay, this is my another account. So okay, and yeah, so this is my ID. Okay, wait. Anyhow, we'll start. Okay, and just let me log into my AWS account here. Okay, my credentials. Okay, and the login. Okay, and multi-factor authentication. Yeah, so let me share my screen. Which, okay, yeah, okay. Let's start with the. Okay, I think, yeah. So, what I'm doing is, so I'm trying to log into the configure the data streams. Okay, so now, so today again we'll create a new one. Okay, so, so yesterday we got to know that like why exactly this is important for us, right? This is data stream is very much important to ingest the data from the data resources. And I have created one lab guide, so I will be sharing the complete lab guide where I have given the screenshot about all the steps and even the code. So you just have to follow that you know uh, the steps. So I will be showing how it will be. Okay, so this will be the lab guide. Okay, so I have given the screenshots and even the steps I have given. So you just have to follow these steps. And so, and again, there will be in some, stuck up points. I have given what exactly needs to be done with the screenshots. Once you open the AWS account, start doing the lab, right? You just have to follow these steps. Okay, and it is complete the guide. This is one thing. And also the second part, so phase 2 also in the similar fashion I will be providing the details. Okay, so now let's configure it. So let's configure. So I will make it as the 2. Let's do the provisioning mode. So we will be doing the one number of shot because we have very smaller one, correct? So, and the 1 MB should be okay for us. Here the strats, again I'm repeating, these are like in small the partitions, okay, where the data we from the smart meter will be storing, right? So as we are virtually using our smart meters, we don't require much the bigger storage, correct? So for that reason I'm selecting only the smaller one. Okay, one with the 1000 records per second. We are not reaching that. And also I am like the maximum record size 1 MB is what I'm keeping. So everything else you don't have to worry. Okay, you just click on the create. Okay, so we have created the backbone, okay, where we are trying to ingest uh, the data. Okay, that is one thing. So, and again, once more, I'm telling this region, you have to be very careful. Okay, so if you are configuring in the US East one, it has to be in the US East one. You should not be changing. If you are changing in different steps, the solution will not work. So you have to be very careful about the region. Okay, again, now, so we have configured this. Let's configure this part. Okay, these two parts. So let's configure IoT. So IoT, what it will be doing is it will help our smart meters to talk to the smart meters, talk to our cloud. Correct. So here, if you go into the IoT, so you just we have to create one device. Correct. So this has to be in the managed section. Create the thing, that is Internet of the Things. Correct. Our smart meters or any of the sensors which will be using in the system, it will be things, right? Internet of Things. So for that reason, what they have done is they have given the name called things. Okay, now, yesterday we created this, right? Today we create the new one. Okay, so create the single. We are not making it complicated to understand. To understand this one, concepts, we are keeping it simple. Okay, so we'll create this and we'll give a name. Okay, and coming to the additional details, if you are trying to make a little more complex project, okay, so you can able to explore this. If not, you can able to keep this as an very simple, and whenever you are trying to create a new project, right, try to explore these options. Okay, that is one thing, and you just have to keep it as a default, don't worry. And this one, again, it has to be no shadow. Okay, we'll save this. And as I said earlier, this is very much important to generate the certificate, because we are trying to authenticate the devices, correct? The smart devices. So the what we are using is we are using the AWS provided certificate we are using, and also we are using the private and public key, which are very much required in establishing the connection from our smart meter to the cloud, secure connection, and also the data encryption. Okay, that is one thing. So if we are utilizing the external certificate authority, then you can able to choose it. Okay, so let's choose the AWS provided, and so we have to attach the policy. The policy is very much important here. The policy is telling that the service can able to talk to each other. Without attaching any policy, the service cannot communicate with the other service in AWS. So these are all very much important. You just click on this and you will see there will be in the JSON format the policy. Okay, here what the policy is telling, this is the policy version. The statement, the effect is allow. Okay, so the smart the gateway is allowed. What actions it can able to take? It can able to take the IoT connect. It can able to do the IoT publish. It can able to do the IoT subscribe. It can able to do the IoT resource receive. And on what? On all the resources. When we put as a star, correct, it is telling on all the resources. So in the real world scenario, we will not be doing this. Instead of telling, it can able to communicate to the all the services, we specify the particular service just to make it as a very stringent policy, security policy, right? So for today's lab, what we will be doing is we will allowing IoT to just to communicate with the resources, whatever we are creating. So these JSON policies are very, very important. Okay. So what I will be doing is I am trying to attach this. Okay. Now, so what we have to do is we have to download the certificates, right? So what I am doing is, so I have created one new folder. Okay. And again, I am downloading all the required files in the folder. Okay. So anyhow, we have downloaded the certificate, the public keys, the private keys, and the root certificates. Okay. Now, yes, the smart meter simulator 2 is what we have configured it, right? Okay. So, and also we have attached the policy and everything is done, correct? So, what is the next step? So, next step, what we will be doing is we need to create an rules, correct? These rules telling that whenever we receive the MQTT, the information that the field, right, whatever we have configured from these devices. So what needs to be done from the IoT, right? So this IoT rules will tell the IoT core to talk to the data stream. Okay. So for that, what we will be doing is again, we are going to the IoT core. Yeah. So in select the IoT core, make sure that you are in the right region. So basically, sometimes when you are doing the labs, so this region may change. So whenever you are trying to configure any of the new components, the service, just make sure that you are in the right region. Okay. Again, so now we had created the IoT. So now let's go to the messages, message routing, because the messages are coming from the our smart devices. And here what we are doing is we are utilizing the MQTT. Okay, so that we are creating the rules. So we will not use this. Let's create a new one. I am creating a new rules. Okay, and okay, we have to provide, okay, name, it has to be underscore. Okay. Now, so this has to be dynamically what we have to do it, correct? So when I say dynamically, all the messages what we receive from the smart meters, so the system, the IoT should take care dynamically. So we don't have to manually do anything, right? For that reason, what we will be doing is we will run one small query. This is an SQL query telling the IoT core. So select star means all. Okay, you remember this whenever you you try to simulate something, or do SQL or Python or whatever it is. When you put an star means it's all. Okay, what I'm doing is I am selecting all from smart grid meters. The plus indicates we can able to add more devices, and it will be, it will take the information from the field devices. That is the simplest the SQL query what we are trying to do is. And also the star is like it will allow the multiple. IDs, meter IDs. For now, we are utilizing only the 10 numbers, right? For our simulation and for the simplicity. Okay. So let's create the rules. Now, this IoT, so we have to tell this IoT rule to talk to these two, right? So let's say what rule action needs to be taken. So it has to talk to data stream, correct? Because this is we already created in the first step. This is our backbone, correct? So I have selected the data stream. Again, my stream number two, which today we created. And this is the partition key. So the partition key, so initially I was telling the kinesis will have the small shards, correct? The small, the storage, the partitions, correct? So for that, so we are giving one small partition key. Okay. And again, here in this service also, we need to create an rules. So we have to create a rules. So this has to be like, you know, without this, it will be, there will be no communication between these services, the rules, the role, and the policies. Okay. So it will be asking to just give a name. We just have to define the name. And in the background, what AWS will be doing is AWS will automatically add the policies. So if you want to manually do it, then you can able to do that way also. You just have to open it. If you are interested, then it is like in advanced. Actually, in the real world scenario, this is how it will be doing. We don't use the default setting, right? So we will just give it. And if you go to that IAM, so in the search bar, if you type the IAM, that is Identity and Access Management. Okay. So in IAM, what we will be doing is, so there will be a lot of permissions. So I will just show one example. So this is, as this is very much important, right? So in the, if you go here and type IAM, so this is the access management. Okay. So here you can able to add the users. You can group multiple users based on the requirement. For example, let's say we have three groups. One is an substation, or else like any control center operator. Okay. So they might require more, uh, what do you say, uh, more privileges to operate the complete system, right? So we will create a group, and also consider the other set of groups where they need only the read only, and other set of reels they only need the dashboard access. So based on that requirement, we can able to create the users, and also the role, and also the attach the policy. So if you go to the roles, so there will be certain roles already defined. Okay. So this is how we will be defining it. Now let's say we had created one new policy, correct, here. So AWS should be creating a policy, or else let's go here, let's attach an policy. Okay. So these are all by default AWS will be providing. Okay. For example, we want to give the IoT permission to data streams, correct? Kinesis data streams. So if you see, there are different policies. Okay, I will just select for now the complete full access. Okay, just attach the policy. If you open this, it's a very simple JSON statement telling that, so the IoT can able to do the actions, all the actions on all the resources. This is the simplest the policy. Okay, what we will be doing it, right? Okay, so sometimes when you have stuck in your lab, correct, you just have to come here, go to the identity and the access management and check whether any specific resource is missing the policy, because in the latest technologies this security is the very much important, correct. For that reason, if you consider any of the the applications or as the smart device systems, so there is a concept called the policies. Okay, you just keep that in the mind. So this is where we are telling the system what to do. Now let it load for a minute. Okay, so yeah, we had created that, right? Now we have selected. Okay, so SQL statement done. The action data stream is done. The name I have selected the stream name too. The partition, yes, role also I have created. Let's go to the next. Again, there will be a last step. It is the review page. SQL review IAM. Yeah. So here you whenever there is an review page occurs, right? So there will be an IAM role. Directly you can able to click here and check whether you have attached the policy or not. Okay. So this everything screenshot I have given in the lab guide. Okay. You just have to follow that. Now again, let's create. So yes. So what we created this part, IoT rule to talk to the data stream and data stream. Okay. Now what we will do is, so let's try to simulate our the smart meters, right? So for that, what we will be doing is, so we are utilizing our laptop to simulate the smart meters. Again, as per, if you create one folder, right click on that. Okay, so this is what the folder I had created today, right? Right click on that and open with the VS Code editor. If you are familiar with any other code editors, feel free to explore it. Okay. And there are little you know so whenever you open this VS Code, correct, so few packages we need, because we are simulating the uh, okay, let me close this. Okay. Okay. Yes. When so one thing what we need is we need the Python package, correct? So the script, everything I have given. Yesterday there was an error, right? So what there was an error. So we were trying to generate an random numbers. So I will explain. Before that, what we have to do is, first thing, the endpoint. So there is one small the connection, because the smart meters needs to connect to the IoT gateway in the AWS, right? So it needs to have some address. So because so these devices will be in the field side, correct? And these are all trying to connect through the internet. So they need to have the address. This is in the domain name. Okay. So this domain name, that has to be copied from, okay, this specific, okay. If you go here, there is a domain configuration, correct? You just have to go here and see, uh, the AWS will provide the domain name. So this is a DNS name, correct? So for example, if you take any of the website and you type some name, correct? So when you type that name, that those names will be converted into the IP address and so on, and then your browser can able to connect to that specific website. In the similar fashion, the IoT device, the smart meters, what we are trying to configure, it needs to have the address. So this is what you just have to copy this and paste it here. Okay, simpler way. Okay, that is one thing. So yeah, and second small changes what I have done is, so this is the certificate what we have downloaded, correct? And so what I have done is, so instead of these random numbers, I have changed the name, correct, these names. So we just have to match that. Right click on this, simple, just rename so that whenever the code calls this, it has to match the name. Similar way in the private also, we just have to rename it so that the name should match. Okay, here the Python, we are installing some packages. Okay, and yes, we are utilizing MQTT. So we have two ways to do this, correct? MQTT and the Apache Kafka. So make it simple. We are utilizing the MQTT. And so here endpoint, it tells the smart device where exactly needs to send the data. This is the address. It is a port number. Okay. And certificate path. So I am defining. So whenever the code comes here, so it will search for the certificate path, and we are giving the device certificate, right? So it will take the details from this specific, the code, and also the private key from this specific file. Okay, and the root CA. Okay, and yes, so this is the count. Okay, so here I am just trying to simulate the 10 smart meters. You can make it to the 100 or you can make it to the 1000. Okay, so whenever you do this, so the amount of data which is generated is very much more. Okay, for now, just to demonstrate how things works, I have taken only the 10 number of smart meters, and I am telling the smart meters to publish the data at an interval of 5 seconds. So you can able to reduce that to the 1 second also, and also to the 10 seconds or so on. Okay, so what we are trying to generate an the voltage which will be in between 220 to 240. You can change this number if you are interested, make it to 120 or so, whatever it is. So this is just an the random number I am generating. You guys feel free to edit this the Python code. You just have to change these numbers. Okay, and the current also I am just telling 5 amps to the 15 amps. Feel free to change this. In the similar way, the power factor, frequency, and so on. And the payload, this is what actually I want it from the smart meters. Okay, but if you are doing any research or if you are working on any of the new project, feel free to add few more, okay, in this. uh, so based on your project ideas, you can able to enhance this the payload. Okay, it doesn't mean like you have to stick to this. You can able to add more parameters here. Okay, and simulate it. And the MQTT client, because we have to communicate to the AWS through MQTT protocol, right? So this is one thing. Now and make sure that to run this you need to have the Python, correct? Whenever you open the system, you have to check it internally. So do you have the Python or not? Okay. So okay, so in your the laptop, you just have to type the Python 3 version. If you don't have any Python, you just have to install, go to the web, install the Python in your system. Okay, that is one thing. And also the second thing, you have to install the MQTT. So this is one of the client what we need, correct? So I have given the command in the lab guide. Okay, you just have to follow it. After the Python, we have to install the MQTT, right? So this is very much important plugin what we need in the simulation, right? So anyhow, I already installed this, so I will not be able to install once again. So what we will do is, so anyhow, we have renamed the other device and let's run. To run, so what we have to do is, so make sure that type and so this is the Python script what we have created, correct? You just have to tell the Python this specific. Okay, you need to tell the Python 3. If you are in the Windows, you just have to type the Python and select the this specific file. Okay, what it will be doing is, so it will start running. See the output. So this output we are seeing in the laptop. Okay, and the output, the starting 10 smart meter simulation. Okay, and so you see from the smart meter 1 we are getting the data, smart meter 1 with the timestamp, voltage, current, and it is giving the complete the parameter which we have simulated. Okay, in the similar way, see the meter 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so the connected with the result code 0. That means all 10 smart meters are connected successfully, okay, to whatever the address we had given here, correct? It has been connected successfully and it has been able to send the data, right? So let the meters run for a while. Meanwhile, we will configure the other part. Okay, so anybody has any questions here? Okay, so next step what we will be doing is, so let's wait for a couple of minutes so that we will see the output in the Kinesis. Okay, go to the Kinesis. This is the backbone what we have configured, correct? So there will be different option. Go to the monitoring. If you click on the monitoring, wait for at least 2 or 3 minutes so that this will pick up the data which the smart meters where we have configured MQTT, right? From there, the data will come here. Okay, it will take some time. Meanwhile, what we will do is, so we will configure the other part. So what is the other part? Next part. So we will configure the storage for this. Okay, that is one thing, and also we will try to the whatever the information which is stored in this specific stream, correct? So we will take that and dump into the storage for to have that storage, what we need is the S3 bucket. So S3 bucket is the the storage we are utilizing it. So let's go here. Let's copy, make it the new tab, and then let's select the S3 bucket. Okay. So go here, type S3. This is the storage what we have it. Okay. And don't worry about this one. Okay, we need to create the new one. So let's create the new one. And here so yesterday also I was telling, and so you have to be very careful here. Okay, so there is two options: make it to the public or block all the public access. So make sure that you are blocking the public access. If you keep this open, if anybody has the access to this specific URL of this S3 bucket, right, they can able to upload, or so uh, they can able to misuse most of the S3 bucket, and the pricing will come to you. So for that reason, make sure that you are enabling the public access to this. Okay, so let's create an S3 bucket. So what I will be doing is, so I will select the general purpose. I will create, and the second part is this name has to be unique. Uh, so you have to configure such a way that these names should be unique uh, across all the AWS. Okay, so whenever you configure the bucket name, make sure that you are adding some prefixes. When I say prefixes or numbers, so I am adding my name just to make sure that the name of the bucket, that has to be very much unique. So if it is not unique, and if you are trying to put it on the uppercase, then also it will not work. It the name should be in the lower case, and it has to be the unique one. Okay, so sometimes you may get error while creating. It will show it will throw error telling that, okay, so this the name has to be unique. Either you can able to put the name, or else you can able to put your account number, where you can able to get it in the right top end. Okay, that is one thing. Let's create. Okay, I'm blocking. So the bucket versioning, you can able to keep it like that. Okay, and the server side, I am creating the bucket. Okay, see this specific the name structure, the raw data, correct. Okay, now so we have created this. Let's try to connect the get the data from the data stream through the firehose, because data stream cannot directly the write the data to the S3. For that we want some other solution, that is the firehose. What it will do is it will collect the data from here to S3. Okay, so in real world scenario, as we are simulating the smaller number of meters, correct, and in real world there will be an millions, thousands, millions, and there will be lot of devices which will be generating in every day. It will be an GB of data, correct. So manually we cannot able to handle it. For that reason, in the cloud we have a different components. So for that reason only, so you have to be understand why we are doing this. Okay. So you might think it we can able to easily read the voltage and current, right? So we are trying to automate the things, and we are trying to handle the large amount of data here from the field devices. Okay, So let's configure the fire hose. Okay, data fire hose. Okay, so let's create a new fire hose. Now, so we need to select the source. My source is from the diagram. You can able to see for this source is the fire hose, right? This one. I'm sorry. This data stream from where we are getting the data, and the destination for this fire hose is the S3. And one more point I want to mention here is, so let's say you have some idea, the new project idea from your your academic or like your personal, you want to do some projects. Okay, so this is not only for the data stream connection. We can able to do the other options, and you can able to create the destination. So for now I have created the S3 bucket, correct? You can able to send the data to other services, and the Datadog, Dynatrace, the Elastic. So you, once you start exploring these options, you will have different the project ideas, and these are all the options which are utilized in the present the technologies. Okay, so feel free to explore these options. That is one thing. And yeah, so here we will select this streams. We are not trying to do any transformation there, so we will select this. Okay, yeah, this is the important part. So what we are trying to do is, we are trying to collect the data in this specific format. So I have created an data bucket, correct? So which has the raw, and I want to collect the information from the sensor. How I have to store it? From year, it is like in directory. Okay, the year, the month, and the day, and this will be keep on changing. In the next day, again there will be another folder within the S3 bucket, and I will show how the data will be storing in this, right? So for now, you just think based on what exactly I need. So this data, so we are making the partition inside the storage. So for example, let's take in another example. I have an a solar plant, okay, and every module will have the different the sensors. So those sensor, we need to collect the data year wise, and it has to be stored in the month and the day, or else you can able to configure in such a way that based on the meter id. Okay, you can able to create one more the prefixes are like, or else the folder where you are fetching the data as per the meter id and storing those. Okay, and the error output, so I am creating one more folder where if I get any errors, right, so error will go to this specific path. Okay, that's it. And so yeah, and coming to the advanced, uh, if you open this, there will be a buffer, and here I am giving the buffer size of 5 MB. Let's make it too small because we are not generating that much, and let's take it for a 1 minute. Okay, so this is the buffer size. How the Kinesis Firehouse works is, so it will keep on collecting the data. Okay, so this firehose will be keep on collecting the data from the data stream. Once the buffer of this we have set as in 1 MB, correct? 1 MB or else 60 seconds. So once that criteria 1 MB or else 60 seconds met, then the data will be dumped to the S3 from the data stream. So data stream will keep on collecting the data from our smart meters. Once everything is done, this every 60-second, this fire hose will be checking the data from the data stream. Once it is done, it will dump to the S3. Okay, that is where you can able to set the buffer size and the timings based on your requirement. And let me do the compression. Okay, so that the data stored is compressed. Okay, and everything else you just have to leave that as in default. Okay, and here, yeah, so this is again we have to create one IAM role. Okay, as we have selected earlier also, right? You just have to create, click here, create. It will, which I already created, so I am just selecting that. In your case, you just have to provide an, you just have to select this specific option and you will get it. Okay, now let's create then the fire hose. Okay, let's wait for a minute. Okay, okay, it has not taken it. Let me reconfigure once again. Okay, I have selected S3 data source and the bucket. This is my bucket, and let me copy my prefix. Okay, and let me copy my error prefix. Okay, the buffer, let's make it as 1 MB. Let's make it as in 1 minute, and the compression is this. So advanced. Okay, let's go and check the IAM, what policy has been attached. Yeah, so see, it is already attached. If you click open this the policy, you can able to see. Anyhow, okay, so create the fire hose. Unable to create the fire hoses. Okay, wait for a few minutes or try again. Okay, okay, why fire was unable to assume the role, this specific. Okay, let me create once again. It should take, because our policy everything is fine. Correct, see, it has been created. Okay, let's go back, and this is what the fire hose we have created. Correct. Okay, and we just have to wait for a couple of minutes so that the data will be ingested. Let's go to the configuration. Okay, and yeah, see, I have selected. So sometimes we get the errors. Okay, So make we have to make sure that we try to debug it. So we try to understand where exactly the error is coming and what is the error. So when you can able to do that, when you understand the system properly, right, then only you can able to troubleshoot the systems. Okay. So yeah, let's go here. I'm trying to check the policy. Okay. So what kind of policy it has been attached? Okay, there is an successful policy has been attached. So for I will do one thing. I will just try to add one more. Okay. Yes. So my policy, everything is attached perfectly. Let's go to the monitoring. Let's go to the Kinesis. Let's see whether I am getting an. So here we can able to navigate back to the Amazon Kinesis. Select last 1 hour here in the custom. Create apply, and instead of UTC, select the local time zone, and see in our graph we are getting the data. Correct. Let's explore something. Okay. So see, this is the put records. Okay. So we are getting the data from the our smart meters. Correct. So let's select, yeah, which one, incoming data. Okay. The put incoming, the latency is also good, average count. Okay. So the graph tells we are getting the dead data, right, in the real world scenario also. So this is how we check. So we always check whether the field devices are able to communicate to the cloud. Okay. So this is one thing, incoming data. Let's explore this. Let's see, you can able to drop down multiples. Okay, that should be okay. And let's see the counts. Mhm. Okay, we are getting it. That's good. Okay, so data. Okay, let's see the samples. Okay, good. So let's see the number of counts. Okay, the count is increased. If you see the number of counts, right? On an average of 5 minutes, what I have selected, and yeah, okay, 550 records, 600,000 records. Yeah, see, okay. So we are getting the data, and so we will wait for another 1 or 2 minutes, and the data will be available here. So meanwhile, let's take an just short break, just 1 3 5 minutes. Okay, then we'll come back. Echo, stop. Okay, let me share my screen. So now let's see, are we getting the data or not? So this is my fire hose, right? So I'm referring to this part now. Okay, so we have completed the ingestion part. So this, the part is the data ingestion, right? And this part is the data storage part, right? So now let's go to the data firehose, and then let's select this specific stream which we had created today, and go to the monitoring. Let's select last 1 hour. Okay, and the local time, yes. See, I'm getting the data, correct. Let's open this. Let's try to explore it. I have selected every 5 minutes and sample counts. Okay, see the details, the count, the voltage, the current, the parameter which we had configured in the smart meters. We are getting that data here. Okay, so we are good. So see the count. Currently we have increased to 309. So basically this this meter which is up and running now, correct? So we are good now. So let's go now. Let's see in the storage. Okay, so how we had configured, we need in the year wise, correct? We have to segregate that in the year, the month and the day. So let's go here. See, I am getting the data. So this is because while creating the data, the firehose, we had defined, right, the prefix in the firehose. We had defined the prefix telling that I want to store my data inside the raw data, and that has to be in the year. If you click on that, see, I have automatically created the folder, the year. So the year what I want is 2026, right? And again the data has to be segregated in the month. See, automatically the folder has been created, the directory, and inside the month it has to be today's date. See, the date is 17. Okay, the great. We are getting the data and we are storing the data in our storages. Let's see whether the actual data is in this or not. See, if you observe this, every uh, minute, 60 minutes, we are getting the data from the firehose. Okay, every 5 seconds, the our sensor is sending the data, and we are storing in the Kinesis data stream. From the Kinesis data streams, we are consolidated all everything, every details, and we are telling the firehose just to store the data every minute. See, these are all the actual data. Let's see like how the data looks, correct? What we will be doing is, this is the file which we got from the sensor. Let's download this file and let's see how it looks. Okay, so let me save it. Let me save as an output. Okay, so I'm just trying to save it in the same folder. What I will do is open the same code editor. You can use other, but just to make it simple. So this is the file which I downloaded, correct? See, the parameter, the payload which we had defined, correct? Everything is in here. Everything. This is what we wanted, correct, as per the code. In real world, how it will be, the data which needs to be sent from the smart meters, same parameters or else different parameters, that will be sending to us, right? So see the files what we wanted, correct? So we have the meter ID, so meter ID, the timestamp, the voltage. So these are all the actual voltage which we have generated, correct? So this is the raw data, so we cannot analyze it. What we will do is next step. So this part is completed. So this part is completed. Let's analyze the data. So the voltage, current, and so other parameters which we are trying to fetch it, right? So let's try to analyze by using other service called glue. Okay. So till now, anybody has any questions? Okay. So let's open the new. Okay. What we will be doing now. So basically, we have the data which is stored in the S3 bucket, correct? So now we will be doing the analytics part. Okay, so today we will not put the AI and ML model. So that is little complicated. Let's save it for tomorrow's the phase two. Okay, let's try to do the analytical part now, just to keep it simple and just to understand complete system. Okay, later on we will do little more complicated, right? Let's go here, search for the glue. So this is the service which help us to clean the data in the real world scenario also. So the data which we got it, right, so we have saved here, and in the real world scenario this is not that easy, correct? Why? Because in the real world scenario there will be a different type of the sensors, different type of the meters, and there will be different other devices, and all the devices will be sending different kind of data, right? It will be an heterogeneous environment. So we have simulated only one type of uh, what do you say, the sensor here, correct? So you can able to create a different type of sensor with a different payload here, and you can able to make the project more complicated in that way. So that is how the actual the smart grid or smart technology works, right? So it cannot be a single meter in all the complete city. So it will be in different meters, and that is also different to make. It could be an LNT, ABB, or different kind of make, right? And also those devices will give the different the parameter output. So if you are interested, so you can able to make this project still more complicated by simulating different type of the payload, right? Here the payload what we have considered is this one, right? So make try to do the different, let's say, 5 smart meters sending some data, and other 5 smart meters are sending different data, and how you are going to store it in the bucket, and how we are going to analyze it. So as per your curriculum, it's all about the integration and analytics and AI modeling, right? So try to simulate the real world scenario. So in your research paper, or like if you want to publish any of the papers, right, try to take these kind of scenarios and try to simulate it, and you will have the good knowledge on it, right? That is one thing. And I think yeah, so in this glue, let's create one database now. Okay, so these ETL jobs, right, this is very much advanced. Okay, so you don't have to worry about it. So when we will be using these ETL jobs, the visuals and other the big data is like when we have the petabytes of data. For example, so consider you have 100 of not substations, so solar plants, correct? So we are getting in petabytes of data, and 1 GB of data or else 10 GB of data per day. In that in that conditions, we required more powerful tools, correct, to clean the data. When I say clean the data, as I was mentioned earlier, we'll be having different type of sensors, right? So we have to consolidate and bring it to the actual, or else like one single table for the analytics. For that purpose, we use this options ETL jobs. Okay, for now you don't have to worry about it. You just open this in this specific data catalog, correct? We we will create a database. Okay, so how so for this, what we will be doing is, so this database will be created on the data which we are saved in the S3 bucket. Okay, so let's create a database and let's name it as in today's. Okay, and yeah, everything else you don't have to provide. You just have to create a database. Okay, now we have the database. Click on this. Now inside the database, so now we have the database, correct? So we have to make sure that my data is saved in the proper format. Okay, so in the S3 bucket we are saving the raw data, right? So these are all the, it has been divided in the year, month and the day, and everything is in raw data. So we saw that, right? It is the JSON, the raw data. Now what we are trying to do is, we are trying to simplify it. We are trying to clean the data, right? For that, what we have to do is, we need to create one table, right? So what we'll do is, we will create one table inside the database, and we will call this as a smart meter reading. Okay, so we will select the database data source. So this is the database which we created, and now, so let's select the standard, and the data source is from my S3, and let's, this is, so the prefixes, the path. Okay, you have to select the path. So this is my my path, correct? So where it is asking where exactly you have saved the data in the S3 bucket. So we just have to give the path, so that this glue, the system will understand where to get the data, correct? For that, we just need to include the path. So what we have to do is, we just have to uh, select this, the name, and yeah. Okay, so now I am telling the glue where to find my raw data. The raw data is stored in the S3 bucket, and my bucket name is the smart grid, and this is what my bucket name which we had given. In your case, it could be a different name, right? And I'm storing the the data in the prefix, in the subfolder the raw, correct? Because that is what I have given here, right? This is one thing. And the we saw when we downloaded and checked, correct? In this, in the output, we saw this is all the JSON format, correct? So see, the JSON format is an JavaScript object notation, correct? It is all the flavor brackets, the key pairs, and so on. So we got to know that whatever we have generated is an JSON format. So we are telling the system, okay, we are the data which is stored in the raw bucket is in form of the JSON. Okay, now, so this is very critical path. Okay, now we have created the table. Create the table needs to have some names in the column, correct? So without giving the names to the columns, the data will not be stored properly. For that, so the naming the columns is called as, simply think like we are just naming the the columns, and that is called as schema, right? So for that, so manually also we can create. Instead of that, there is small script is there. Okay, so what we are naming the table, we are giving the table as an meter id, stamp, time stamp, voltage, current. So these are all the columns in the table. Okay, so all the data which we are fetching, right, that will be stored. See, this is the column, and I am telling the data type. Okay, so this is the table. Now we just, so, another catch here is, it is not all the data is not stored in the raw data. It inside the raw data we are making the different folders, right? The year, the month, and the day. So the partition needs to be made. So without partitions, we cannot do it. So we just have to add the partitions. Okay. Again, so the month, we need the month because the data is stored as a month, and also it's a day. So you just have to click on the partitions key. Okay. So the partition will help us to segregate the data which we got it from the sensor, right? And also it is stored in. So this is very much important part where we have the partition key enabled. So if you are not creating this partitions key, right? So the data will not be fetched from the data sources, right? This is clear, correct? Fine. So let's go. And one more, let's see whether we have, okay, I think it looks good. So the final review and create table, yes. The path, yeah. And the classification is JSON. And the partitions, yes. So we are creating the partitions. Yeah, let's create the database, the table, and the schema. Correct. Now this part is completed. We have connected the glue to the S3. The glue, we have the database, correct? Now let's see, we can able to query the database. So in the real world scenario, we are saving the the complete information in the database, correct? After that, we do the query. When I say the querying is like we try to get the information like what is the voltage, and what is the frequency at a specific time. So that kind of the query is what we have to do it, right? For that, what we needs to do is Athena. Okay, okay, yeah. So see, this is an query editor. Okay, so this is kind of think like if you want to pick specific data at a specific time, let's say in your operator, or else like any specific person comes to you and asks, okay, can you able to give the status of the specific meter, or else like a specific device in the field, uh, about the health, or like at that specific time what was the power generated or power consumed, what was the voltage status on that specific time, correct? So how do you do that? So you cannot go and search for the millions of record. For now we have the 10 meters, we can able to do the manual search. But when you have the thousands of records, the millions of records, how do you do that? So to do that, we have the query, correct? So when sorry, so we need to do the query, correct? It's all, you just have to have the little knowledge about so this query language, and let's edit something, and okay, let's select. So now whenever we do the query result has to store somewhere, correct? So it is asking, if you do the query, where the results needs to be stored. So what I will be doing, I will select the same storage as my the raw data. So I am choosing the same. Okay, I will be selecting it. So here the query result, it will be stored in the same location. Okay, let's go back, and so one important step we need to do it, right? So here in the data source, you have to select the catalog. So that will be okay. This is the database. This is what the database which we had created, and this is the table. Okay. Right now, table don't have any data. Correct. We have to run the data. So let's start. Okay. Let's try to match that. Okay. Fine. Now this is the command which I already given in the the lab guide. Okay. So what it will be doing is, so it will try to, so this data, the table which we created, that has to match to our S3 bucket data source, right? So this command will help us to the match this, and also the partition, right? So let's try to check the partitions. Okay, this query run against, okay, unless, okay, uh-huh. The systematic decision table not found the smart meter readings. Why it is not? Okay, let's run the system once again. Yeah, okay. Let's see the partition now. The query run against the smart meter unless qualified by the hmm, semantic design. The trouble is the table is not found in the smart meter. Whether I have selected the proper table, the data's catalog, okay, and data which I have selected is the proper only, and why it is not coming. Let's troubleshoot. Okay, let's try to run the different command. Let's see. Hmm. The find the okay. This query run against this unless qualified by the query. Let's see the IAM role. Okay, let's go to the IAM. Let's check the role, and mm, 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 mm. Let's try to query the other DB. Okay, let's see. I have selected my older DB. Okay, let's go here. Let's run the, yeah. See, see in this specific the table, you can able to see the meter ID, the timestamp. So this is, it is the query what I have selected. See, the query is select all from the smart meter reading and the limit 10. So I am just trying to limit specific, uh, only the 10 records. So there are lot of records which is coming up, correct? So I am trying to only limit this. See this IDs, the timestamp. Okay, these are all the voltage, the power, the frequency and power factor. Correct. This is how it is, right? This is the query result. So let's run another query. Okay. So what we'll do is we want the meter ID, and the output is the average, the power, the power in the kilowatt. Okay. And from where? From the smart meter readings, the table, and I have to group by the meter ID, and the order is by the average kilo. So let's run this query. See the output. If you see the output, I have the meter ID. Okay, this is the average. So you see the average power, correct? So specific, the meter 004, it has the very the less power is what we are getting, and the meter 6 has the highest the power rating, correct? So this is how we can able to query the our data, correct? And again, let's go here. Let's do another query. Here what I want, based on the the meter, I want a minimum voltage, the maximum voltage, that needs to be sorted on the basis of the meter ID. Okay, this is the meter ID, and yeah, so from where we have to select from the smart meter reading, and it has to be grouped by the meter ID. So let's run this query. See the meter, the specific meter ID. So the meter number 6, it has the minimum voltage at 223, and the maximum was 235. Okay, so this is the basic query what we usually execute. You can able to make it more complicated, telling that at a specific time you can add any specific time here, and you can able to check what was the voltage at a specific time. Okay, so that is one thing. And let's do another query where we are asking select all, the star is all, right? From the table, the smart meter reading table, where the power is greater than 2.5. See, we got the complete information. Okay, the meter 1 at a specific timestamp. Okay, the voltage was this, the current, the power is this, and the frequency, the power factor, and other details, the year, date, and also, as I was mentioning earlier, this this query can be done on a specific day and also based on the timestamp. So the timestamp can be an you know uh, the filter criteria here. Okay, this is clear. Now we have done the Athena also. Now what we'll be doing is we will do the visualization part. So we will not integrate the AI and ML on this. We'll try to do the visualization now. Okay. To do that visualization, what we have to do is we have to go, let's open another tab. So till now, anybody has any questions or everything is clear? Okay. So I believe everybody is understanding the concepts, right? So I know this will be an very much difficult, but at least try to understand what is the use case, right? So, and again, I'm telling you, so this is what the real world is utilizing the technology. Okay, it is not like oscilloscope where you are seeing the the graph or some parameters. No. So currently, the how the technology has been utilizing is all about the analytics, right? So only so you cannot predict these values, right, by using the waveform. Like if you might have used the MATLAB and Simulink, right? So you cannot create an the bigger project on the MATLAB or Simulink, and you cannot simulate the real world scenarios. And if you say you want to do the prediction or like you want to run some analytics, right, on that, it will be very much difficult. So think this is what every system, every big organization, or like if we have any big industries, right? So they are adopting this. Okay, so for that reason, I'm trying to make you understand what is the use case of this technology. Okay, so if you have any questions or doubts, let me know. I'm happy to assist you guys. Okay, and don't worry about these queries, and everything I have given in the lab guide. Today I will be sharing for the phase 1 and try to simulate it, and sometimes you may run into the errors. Okay, and try to figure it out. So what was the error? And most common errors will be the IAM. Okay, so where the specific the resource will not be able to communicate to the other resource, right? In that case, you just have to go to the IAM, check the the permissions. Okay, so if that specific resource don't have any permissions, then yes, obviously it may not be able to communicate to the other services. So that is how one thing you have to do the troubleshooting. Okay, so when you do the troubleshooting, then only you will understand the technology, or like this AWS. That is one thing. So let's do the visualization now. For that, quick site. So first time when you when you open this quick site, right? So it will ask, so it will ask for the subscription. Okay, and again, it is very much important to delete all the resources when you have done it. Okay, if you leave the resource running in this AWS, it may you may have to pay the amount. So anyhow, you will be having $600, $100, which will be given to the given by AWS, right? That will phase out. So I am trying to log into my system, my account. Okay, so I just logged in. Let me. Ah, okay. Yeah, yeah. So the quick site. this is an intelligent. So in the background, again, there will be some, AI and ML running. So for now, we will not be worried about that. Okay. So when you try to open this, it will ask for your email ID, and you just have to provide your name and email ID, and that email ID should be the same of the AWS one. Okay. So what it will be doing is, so this will map to your AWS account, and the same credits will be utilized. Okay. And you don't have to worry about anything. So this is the quick side is an data visualization platform, right? So now why we need this data visualization, because in the Athena, if you are expert in the SQL, or like you can able to create one some SQL queries, then fine. So whatever we have seen, correct, we can able to do the query. So, and if you are like an expert, if you are an electrical engineer or so on, you can able to see what exactly happening based on this, the values, the current voltage and the power value, correct. But where if you are presenting to someone, to your either to your management, or like any of the uh, the board management, right? Or else if the operator wants to see in an visualization manner, how do you do that? So you cannot send this table and ask them, okay, see the table and do the visualization. You cannot do it. Okay. So for that, what we have to do is we need to do the visualization part, correct. So in this, what we will be doing is, we will do the visualization based on the data which we have received in our bucket. Okay, that is one thing. So yeah, we will break for a breakfast, and another like 20 minutes we'll come back. And in this session, what we will be doing is we will be visualizing our data, okay, in terms of bar charts, or like you know uh, various different form of presentation of the data, and we will also see how we can able to interpret the data, right? Okay, so we'll break for for a breakfast, and we'll come back. So now we are in the last part. So where so we are trying to visualize the data what we are fetching from the smart devices. Correct. Now we will be talking more about the this last part, that is the quick site one. Okay. So now let me close this window. Yeah. So the first thing when you the login to this specific quick site, so you will be prompted to create an account. Okay. Once you have done that, so there will be you have to link this specific quick site to your the normal AWS account. Then this is the page you will get it. Okay. And the first important thing is, so as we did for the other services also, we just have to give the permissions. Correct. So you just have to go here in the quick site suite. Correct. So you will have this the managing the account. Okay. So if you see here, if you scroll down to the permissions, because this quick site needs to have the permission to get the details or from the S3 and other resources. Correct. In the permissions, you have to select the AWS resources. So once you selected that, correct, so there will be an different options uh, which is available. So this is all about the providing access. So why this is necessary? Because in the real world scenario, so it is not only the one user will be working, right? So there will be a lot of users. If it is a centralized central centralized monitoring station. Okay. And so in the centralized monitoring station there will be an 10 to 15 members of uh, the engineers who will be monitoring the complete installation, right? So in that conditions we need to have the different roles, and with the different roles we will be attaching the policies, and the policies will give the privileges to the engineers. So when I say the privileges, few engineers needs to have a read only access, and a few engineers needs to have the read and write access, and the main assume that we have the even the director who wants to visualize this dashboard, right? He needs to have the complete access to this data as well as dashboard. In that conditions, how we are going to do is, this is based on the IAM rule. Okay. You can use the self-managed rule, or else you can create your own rules. For now, to keep it simple, what we will be doing is we will use the self-managed, the simpler role. Okay. Now here the quick site. So it is we can able to allow or else restrict the access of the quick site to the databases, or else the resource which we have created earlier, right? So what I have done, so for my different the projects I had enabled the access to the Redshift, RDS, IAM, and even we have the buckets, right? So even let's, this is how when you scroll down we'll be having the different buckets. So we just have to select that, and yes, you are telling the quick site, okay, you are allowed to use this specific resource in the AWS. And also if you are working on different project, and that project involves other resources like storage analysis or else open search, the sagemakers. So sagemaker is what we will be utilizing to deploy the AI and ML model, but not today, and this will be in tomorrow session. Okay. So in that case also, to visualize the AI and ML the outputs, we need the SageMaker, right? All the prediction, all kind of the machine learning will be happening in the SageMakers. If you want to allow the QuickSight to have the data fetched from the SageMaker, you just have to enable it. If not, you can able to disable it. So once everything is done, you just have to click save. Okay, so you just have to review that what is the outcome, and then you just have to click OK, right? So that is the one thing we have to do. And the second part, so sometimes you may get the error. In that case, you just have to go to the IAM again. In the IAM role, search for the quick site. So we selected, if you remember, we selected when we went to the manage quick site, there was an IAM role. So I was mentioning about two things, correct? Here, here, the quick site managed role. This is the default role. Okay, I had selected this, and also we can able to create the new one. So this is the one, it got selected. Okay, so what permissions this specific policy is having. If you open this specific policy, so it can able to get the information from these resources. Okay, this is the actions. So see here, it is allowed to do the list bucket, so it can able to get the information from the source, the get the object, and so on, correct? And other one, other resources, if you see here, why these are all the Athena one, right? So the query engine, what we'll be using to query the S3 bucket, right? So all the necessary actions, what is needed, it is given in this policy one. Okay, so if you are not providing this, then you will not get the output in the this quick site. Okay, so be careful, and also make sure that if you are facing any of the issues, try to check the IAM role. Okay, so here, just to reiterate, so we have this Athena, right? So where we are doing the query from the glue is where we are trying to put all the raw data which is in the S3 bucket into the table format with the proper schema, right, in the columnar and everything. And then that table will be queried by using the Athena. So now Athena, from we are fetching the details from the Athena, and we are doing the quick site, that is the visual representation of the data, right? So for that reason, what a quick site need is that need the output of that need the permissions to get the output of Athena, as well as it also needs to connect to the S3 for the fewer options, right? For that reason only, what the policy is telling, it is giving complete Athena as well as S3 bucket policies, right? So this is one of the troubleshooting the techniques you need to get familiarized with, right? That is one thing. And let me go back. So now the permissions, everything is set. So what we have to do is we need to create one data set, right? So data set is, see, this is, let's go and create one data set. So let's create a data source now. Okay. So again, if you have any of the project ideas, right? So in that you are using different resources. So you can able to directly connect the quick site to that resources. For example, you might be working on some the time series where you probably might be studying the solar radiation, the behavior. Okay, so when you try to study the solar radiation behavior in the PV cells, or like in the solar plant, right? So every details will be in the milliseconds, and that data will be stored in the time series, right? So these time series, we can able to store that and directly connect this quick site to have the visual representation of the solar radiations. Okay, that is one thing. So that is what you can able to come up with your own ideas and do the complete solution based on this, right? For now, what we have done is we need to select the Athena. Okay, so let's go here. Let's select. Let's tell us provide the name for this and the creator one connections. So we are trying to connect to the database. Okay, select this. For now, let me select the earlier database because we have the data available in this specific database, right? So for that reason, I'm selecting that, and I am selecting the table. Click on select. So what it will be doing is, so this will have the visual representation ready. Okay, click on that. So we need to wait for a couple of minutes. Okay, and because the data needs to be fetched from the uh, Athena, right? So we need to wait for few minutes. Till then, what we'll do is we'll explore the other options what we are having it. So now, where if you go to the home, right? So you will have the recent uh, the analytics what you have done based on the data what we got it, right? So you will get it here. And also the good part here is if you don't know any the query or something, you can able to directly chat by using the chatbot, and that will help you create the visualization. Okay, and other integration also we can able to do it. And coming to analytics, the dashboard, if you wants to create some scenario based, you can able to do it. Okay, and the data sets, so data sets is what we created a minute ago, right? So this is what it is. Let's go here. See, when you click on the specific data set, what it will be doing is it will show you the status of the data set. So now the size of the data set is very small because we are getting only the little data, correct? And also the refreshed, I have imported 12 rows. Okay, and the last refreshed was on the February and today. Okay, so this is how we can able to see whether the latest the data is available for the analytics or not. Okay, let's go to the analysis. Let's select. Okay. Just a minute. Yeah. So when you go to the analytics analysis, so you will have this kind of dashboard. Okay, when you click on that, so you can able to select the different type of visualization what you need. So let's say for now, let's say I want to visualize this in the bar chart. Okay, so let's try to get the average load per meter. Okay, the feeder view. Okay, so what will I will do is I will select the meter ID. Okay, and then also I will select the power. See, we can able to get the visualization, right? So here also you can able to do whether you want ascending order or descending order. This is the visual representation. So you can able to see the specific meter. Okay, let's me close this specific meter and what is the power. Okay, and the meter one has shown the higher power, that is the 12 kilowatt, right? And this is one thing. And we'll do one thing. Let's rename this as an average load per meter. Okay, you can directly click on this and enter yeah, the name. So I'm telling this will be my average load per smart meter. Okay, this is one thing. Let's see another real time one. Let's click on the add new. So in this, what I will do is, let's scroll a bit. Okay, and what I will be doing is, so again, line chart. Let me select the line chart. Okay, let's select this. And in the x-axis, what I will do is I will select the timestamp. Okay, and what we'll select, other one, we'll select the power. Okay, and then we need to have the power, this one, right? Okay, so for that, let's see what we have is, this is the demand, right? The average. So let's rename this. Let's rename this as a load profile over the time. At what this is giving is, this is giving the complete information of the power consumption, right? The load profile with the timestamp. So what we are trying to do is, we are selecting the timestamp and we are putting a graph. See, the consumption has been decreased, right? This is how we can able to forecast the, or else we can able to, this is not actually forecasting, this is the historical data for the analysis. So as the time goes, right, so here the time, the power consumption also, it is getting reduced. So this is one thing what we can able to analyze. And another bar chart, we'll do the, now we have done the bar chart, line chart. Okay, let's try to do some the table one. Okay, so in table what we'll do is, the meter id. Okay, so let's group by meter id. Okay, and what we will do is, we will add the value, and so here, click on this, let's see the voltage parameter now. So if you go here, and let's say I don't want complete sum, I want an minimum. Okay, let's select the minimum, and also I want to see the maximum voltage reading, right? So here, let's see now what this table will is giving. So this specific id, the voltage, the minimum voltage was 221 and the maximum voltage which was recorded was 239, right? And the meter number 4, the minimum was, the minimum and maximum was the same. Okay, in this specific the meter number 6, right, 223, and the maximum was the 2. Okay, we'll do one thing. So this is the stability analysis. Let's give it a name of stability analysis. Okay, and so we have 4. Let's create one more. Let's create an KPI table. Okay, so we'll see the power factor. Okay, let's add the power factor here. Let's drag it and drop it. Why the power factors? Let's say it should not be an power factor. Okay, so now what I am doing is I am I have created one power factor. Let me rename this. It's okay. So we can able to keep it as in the power factor only, right? So now the average power factor. So you can able to change that. Okay. So this is what we got it. One we have plotted the meters with the kilowatt and the power trend over the time and also the power factor. This is an average power factor. Okay. And this is the table to get the minimum and maximum. Okay. So you can add more visualization. So so this is one thing, and so there will be an different options available. You can able to mix and match what parameters you need. Okay. So this is one thing. Yeah, I think we are good here. So anyone has any doubts? So this is the dashboard, and in the real world scenario, so this dashboard will be shared to the required members, so they can able to do some analytics. If you want to change any parameters, they can able to do it, or else you as an operator you can able to predefine the parameters so that only the read only access can be given to the required personals, right? And in the tomorrow's class what we will be doing is, so this is the historical data, correct? Now how do we predict if some theft is happening in any specific feeder or like something like that? Okay, so how do we detect that? So in the tomorrow's class what we will be using is, we'll be using the AI and ML model, that is by using the SageMaker. Okay, from the SageMaker, so we will predict so what could be the load in the coming future. Okay, that is one thing. Yeah. So that's it. Like, um, I will just once again show you what exactly we have done. So basically, and also I want to show this. Yeah. See, my meter is still running, and if you want to stop the meter, you have to just Control C. When you type the Control C here, so the meter will automatically stop, because this is a virtual meter what we have configured, right? So this will stop, and now we will not get any data. So let's go back, let's close this. Now we have simulated the smart meters, and the data we are sending through the internet to the IoT core. So IoT core will be having the rules where it is telling the all MQTT, the messages what we have received from the smart meters needs to be sent to the data streams. In the data streams, we will be having small partitions, right? So in the small partitions, or else we also call it as in shards. Okay, so in that we had configured, we need only one shard. It could be in thousands of millions in the real world scenario. Okay, for our scenario we selected only the one shards with the 1 MB, or else 1000 records per second, right? So that is one thing. And so we connected the data streams to the fire hose. The fire hose is where it will collect the data from the stream, and it will help us to store the data in the S3 bucket. So S3 bucket is the storage device which we use, correct? And from the storage we are creating the table, because in the S3 bucket it is all the raw data, correct? So raw data we cannot do the query directly, or else we cannot have the visualization directly from the raw data. So what we are trying to do is we are creating the neat table with the schema. So in the schema we have created the different profiles, the current, the voltage, and the power factor, right? So that is the table we have created by using the glue. And also we have created the database within the glue. From the glue, by using the Athena, we did the query. So the basic query is what we execute. And then once that is done, we are utilizing the quick site, okay, to have the visualization. So this is about the phase one project. Okay, so anybody has any doubts? Okay, so the next very important part is, so we already created many resources, right? It is very much important. We need to delete all the resources. Okay, if keep these resources running, you will end up with losing the credits which the AWS has given, right? So we'll start uh, removing the resources. So first to start with the database removing. Okay, so let's remove this. Okay, and even the tables. So tables automatically it will be removed. And let's go to the S3. So in the S3 where we are storing the raw data, correct? So first you just have to go to the storage, and first we need to empty the storage. Without emptying, we cannot delete the storage, right? So we just have to go here, delete it, and then exit, and then this specific needs to be deleted. Okay, now we deleted so let's track from here. So we deleted this, and the glue Athena will be in serverless. We don't have to worry about it. And the quick set also we have to delete. And let's go to the Firehouse. Let's go to the Firehouse. Select the Firehouse stream and select the required Firehouse that needs to be deleted. Okay. And then let's go to the data streams. In the data streams, select the one which we needs to delete. Go here and the delete. Okay. So now we have deleted the data streams, the Firehose, this and this. So let's delete these two. Okay, IoT. Let's go to the IoT. Select the things. So before that, the MQTT, right? The rules. So these MQTT rules which we had created, let's delete this first. Okay. So that is one thing. And then coming to the IoT, go to the all device things. Let's select this. Select this and delete. So what it will be doing is it will remove the certificates first. Okay, then the all the authenticated the public key, the private key, everything will be removed. Now let's go to the rules. Probably we deleted the rules. Yes, we deleted the rules, and we also deleted the thing itself, right? I think we are good here. So we deleted this, and this, and the quick site. To do the quick site one, you just have to go here, here. So in the manage quick site, you need to, in the account settings, oh sorry, in the manage subscription, you need to remove the managed one. Also in the account, you have to terminate the account. Okay. If you are not terminating it, it will be keep on running in the background. So it might occur, it might cost you some dollars. Okay. Why I am keeping is like because tomorrow we need to have this, right? So in that, for that reason only I am just keeping. But in your case, once you have done everything, you just have to remove this. Okay. Yeah. So that's it for today's class. So let me know if anyone has any doubts. Was that easy or difficult? How was it? Could able to understand or not? Everybody understood? Hmm. Okay. So we'll break. Okay, today's class. Thank you.